Imagine looking out at the horizon, realizing the only water available to you is the ocean. It covers the vast majority of our planet, but drinking that crashing salt water directly will quickly dehydrate you. Over the next 5 minutes, I will show you how to build a stovetop desalination unit using basic kitchen tools to separate salt from water. Before we start, this is an educational demonstration. Seawater contains bacteria, microplastics, and pollutants. Do not drink untreated seawater without using certified, safe purification methods. Today, we are building a small-scale purifier to show exactly how basic science can engineer clean drinking water. To build this system, you need 3 main pieces of hardware: one large pot, one smaller heat-safe collection bowl, and a curved pot lid. You will also need your source of dirty salt water, a clean filter cloth, some ice cubes, and a pair of heat-resistant gloves. These are everyday household items that, when assembled correctly, they recreate the exact physical processes used in global water purification. Step 1 is pre-filtering. Before we extract the pure water, we have to physically remove any suspended debris, like sand, dirt, and seaweed. Take your source water and pour it slowly through a clean cloth or a fine mesh screen into a secondary container. Compare the 2 containers. The murky input water goes in, and a relatively clear liquid comes out. However, this pre-filtering step does absolutely nothing to remove the dissolved salt. The water in that secondary container is still fully saline. We complete this pre-filter step because removing solid debris prevents the main distillation chamber from clogging or burning during the heating phase. Now we set up the distillation unit. Place your large pot on an unheated stove and position your small collection bowl exactly in the center of the pot. Slowly pour your pre-filtered salt water into the large pot. The water should completely surround the small bowl, but the inside of that small bowl must remain completely dry. Be careful here. Do not fill the main pot too high, and do not let a single drop of salt water splash into the empty collection bowl. You have now created 2 physically isolated zones: the saltwater ocean at the bottom and the empty freshwater island in the middle. Next, take your pot lid and place it on top of the large pot upside down. When heated, liquid water gains energy, turns into vapor, and rises. Heavy salt molecules cannot evaporate, staying trapped at the bottom. The pure vapor hits the inverted lid. Gravity forces condensation down the curved slope, dripping into the collection bowl. To accelerate this process, place ice cubes directly on top of the inverted lid. Creating a boiling environment at the bottom and a freezing cold surface at the top provides the intense temperature contrast that drives a fast distillation cycle. Turn the stove on to a gentle simmer. Do not bring the water to a violent boil, because large bubbles will cause salt water to splash up into your clean bowl. Never clamp or permanently seal the lid onto the pot during heating. Trapping expanding steam will build pressure and cause a dangerous explosion. Watch the underside of the lid. The rising steam hits the cold metal and immediately condenses back into heavy, pure water droplets. After 20 minutes, turn off the heat. Put on your heat-resistant gloves and lift the lid straight up. Do not tilt it, or the melting ice water on top will spill into your pot. Look into the center bowl. You now have a pool of clear water, confirming the physical extraction of H2O was a success. Carefully pull the small collection bowl out of the pot. Compare this perfectly clear yield to the murky salt water you started with. Now look closely at the bottom of the empty large pot. You will see a thick, crusty white residue left behind. That residue is the salt. Because salt requires incredibly high temperatures to evaporate, far hotter than a kitchen stove can reach, it was physically stranded in the pot while the water escaped as a gas. Seeing that remaining salt proves exactly how this works. We achieved total purification purely through physical temperature manipulation, with 0 chemical reactions required. This exact same science keeps people alive in isolated environments. Large maritime vessels at sea rely on these identical principles to generate their own fresh water far from port. Massive industrial plants scale this physical separation up to incredible levels, providing thousands of gallons of daily drinking water for entire coastal cities. You can test these principles outdoors yourself. Try building a passive solar still using just a shallow hole in the dirt, a plastic sheet, and the heat of the sun. Clean water is widely treated as a limited resource you simply have to go find. But with a solid grasp of basic physics, it is a resource you can engineer yourself, anywhere in the world.